Hello and welcome to the Edexcel Further Maths videos for Mechanics 1. This is Collisions in 2D, section 1.2, Loss of Kinetic Energy in an Oblique Impact with a Fixed Surface. So kinetic energy, the amount of kinetic energy lost is influenced by the elasticity of the collision. We know from our previous video that the coefficient of restitution is dimensionless and that it is between 0 and 1. 0 means that the objects would join, and 1 means a perfectly elastic collision, which means no loss of kinetic energy. So we're interested in the change of kinetic energy, and that is the final kinetic energy subtract the initial kinetic energy. Kinetic energy is a scalar, and when we have a negative answer, that means there's been a loss in kinetic energy. So if we think about an oblique collision with a smooth plane, we've got a fixed plane, but we can apply Newton's law of restitution, which is perpendicular to the fixed plane. We have our direction before the impact and then our direction after the impact. Obviously for kinetic energy, it's a scalar, so we need the speed before and the speed after rather than the velocity as a vector. So here's an example. A ball of mass 1.5 kilograms is projected towards a smooth plane. We want to find the loss in kinetic energy of the particle during the impact. So we are given here the coefficient of restitution, and we've got the initial speed, which is 4 meters per second. So what we need to find is, we know that we've got U1 and U2, and V1 and V2. Now the speed parallel to the plane doesn't change in the impact, it's just the speed perpendicular to the plane that changes. U1. So in this particular example, U1, if we use our trigonometry, is going to be 4 cos 45. Which means that V1 is also going to be 4 cos 45 because this does not change. If we look at U2 down here, we can see that that's going to be 4 sine 45, and V2 is going to be E, which is 0.4 multiplied by 4 sine 45. Now, when you're doing your calculations, it's absolutely fine to keep everything in surd form while you're calculating, but generally in mechanics we give answers as rounded decimals, usually to 3 significant figures. So, if we complete these calculations, we find that the velocity after the impact is minus 1.13 I plus 2.83 J. Now, as we're calculating the kinetic energy and the loss in kinetic energy, what we actually want is the speed. So the speed here is 3.05 meters per second. So the calculation for the change in kinetic energy is a half mv squared minus a half mu squared. So when we do this calculation, we get 6.96 minus 12. So that is minus 5.05. So that's confirmed we've got a loss, and in fact our loss in kinetic energy is 5.05 joules. Okay, next time can you join us and watch the 1.3 video, Successive Oblique Impacts with Plane Surfaces.